To start this series, I'm going to perform a bit of a mind trick. I'm going to ask you a question, and I want you to think about the answer, and I will read your mind through the internet. Okay? What is the absolute coldest that something can be? I'll give you a second to think about it. Time's up. You guys had a lot of answers. Some of you straight up answered the question of the episode, others got it within the ballpark, some of you were thinking about cat videos, and a couple of you thought you were being funny by thinking about lava. So let's go with the most common answers, those being ice, Antarctica, and liquid nitrogen. Ice has a base temperature of 0 degrees Celsius, but it can get even colder matching the air temperature, so if the air is minus 20 degrees, then the ice will cool down to meet the temperature. In the South Pole, the average winter temperature is about minus 49 degrees, with the lowest temperature of the poles being recorded in 1983 at Vostok Station, measuring at minus 89.6 degrees Celsius. Surprisingly though, it's liquids, not solids, that can get colder than this. The most commonly known of these liquids being liquid nitrogen at minus 196 degrees Celsius. But thinking back to that periodic table for a second, if liquid nitrogen is that cold, then how cold can liquid elements get? Well, the coldest would be liquid helium at minus 270 degrees Celsius. It gets crazier than this because those freezing liquids can actually become solids. Solid helium is, in fact, minus 272 degrees Celsius. For comparison, space is really cold. Like, really cold. It's so cold that the moisture in your mouth would be brought to what is known as a cold boil. Space is minus 270.45 degrees Celsius. Now, as at this point, you're probably wondering what Kelvin is and why we can't seem to get any negative values with it. Well, we've reached the end of our explanation, so allow me to explain. Kelvin is used as a measurement to show how much hotter than absolute zero something is. What is absolute zero? It's 0 Kelvin, the coldest possible temperature that is physically possible in the universe. At 0 Kelvin, all molecular movement stops. Kind of. Honestly, to really get in depth about it, we'd have to get into quantum mechanics and zero-point energy. Basically, atoms stop moving in the usual sense, but still vibrate, and this technically counts as movement. So there you have it. The absolute coldest that something can possibly be is, ironically, at absolute zero, where it gets very heavy into quantum mechanics. Not really that surprising when you're dealing with absolutes, eh? So, thank you very much for watching, ladies and gentlemen of the internet. I've been TigerJ15, and this has been The Absolute. Cheerio.